describing a relation in list form, or in other words the roster form. So, here we are going to describe a relation in the list form, or in other words the roster form. So, here in case of a roster form, whereas in this method we will list out all the ordered pairs that satisfies this relation, the given relation, by means of formula, by writing all the ordered pairs and then separating the ordered pairs, that is the elements, by means of commas, and then enclosing within the brackets will gives us the list form, or in other words the roster form. So, we are going to discuss this topic under the advanced level. So, now, we have stated that in case of a roster form, we will enclose all the ordered pairs by separating them by means of commas. So, here the list form or the roster form of describing a relation. So, here in this method we list out all the ordered pairs that satisfy the formula that is given in the relation. That is, we have to enclose all these ordered pairs within the brackets by means of commas, that is separating the ordered pairs by means of commas. So, now let us illustrate by means of one example, that is illustration number 1, or in other words the example under this. If set A is equals to, the elements of this set A are of 4, 5, 6, then let us write the given below relations in A in the roster form. So, here we have to list out all the ordered pairs in case of the roster form, whereas here in this the first one is of, let us consider the first relation as R1 is the relation having the property or in other words they having the formula that is equal to, so R1, the formula of R1, that is the first relation, is of E is equals to for this relation or for its elements. whereas the second one is of, we are assuming the second relation as R2. So, R2 is the relation having the formula, or in other words having the property that is less than. So, here in the second case, that is the formula of R2, the second relation R2 is of is less than for its elements. And similarly, whereas in the third case, so we have to write all these elements in the roster form. So, here we are assuming the third case, that is the third relation as R3. So, R3 is the relation having the property or the having the formula that is greater than. So, here is greater than is the formula for the relation that is R3 for its elements. Then now solution starts now. So, in our solution, as per the problem, the set A elements are of set A elements are of 4, 5, 6. Then now the relation is nothing but the Cartesian product of A and as well as A, that is A cross A. Then now here, in order to get the relation, that is R is equals to A cross A, then that is equals to, so here the elements of A are of 4, 5, 6. So, here already I have stated that in order to get the relation, we have to find out the Cartesian product of A and as well as A. So, here A cross A equals to, so here first A, so here elements of A are of 4, 5, 6 cross. Then now the elements of again A, set A are of 4, 5, 6. Then now here we are going to find out the Cartesian product of A and as well as A. So, here that implies the relation R is given by means of, so here with 4 will be the first ordered pair, then now next ordered pairs will be of 4, 5 and 4, 6 with 4. Then now with 5, 4, 5, 6 will be the next 3 ordered pairs, and similarly with 6, 4, 6, 5, 6, 6 will be the last 3 ordered pairs. Then now the relation consists the ordered pairs as 4, 4, 5 and the third order pair will be of 4, 6. And with 5, that is 5, 4, 5, 5 and 5, 6. And with 6, 4, 6, 5 and 6, 6 will be the last ordered pair. So, here we are enclosing all the elements, that is 4, 4 is the first element. Similarly, there are of, so 3 elements in the first set, that is A, and 3 elements in the next set, that is A. So, 3 is of 9, there are of 9 elements, or in other words 9 ordered pairs. Then now here, in order to write in the roster form, we have to enclose these elements within the brackets by separating them by means of commas. So, here this is the roster form of the relation, that is R, given relation. And from this, as per the question, so here first of all the case number 1. So, here in case number 1, we have to write the relation R1. So, here the R1 is given by means of, so relation R1 is a relation having the property that is equal to for its elements. So here there are of 9 elements of the relation that is R, 4 comma 4, 4 comma 5, and similarly and so on up to 6 comma 6. There are of 9 elements or 9 ordered pairs. So from this we have to choose the relation R1 in such a manner that the property is of E is equals to. So here this E is equals to satisfies this condition, that is R. So here, whereas as per the problem, so here R is given by means of the relation R is equals to 4 comma 4, 4 comma 5, 4 comma 6, but the relation R is given by means of 4 comma 6, 5 comma 4, 5 comma 5, 5 comma 6, and similarly 6 comma 4, 6 comma 5, and 6 comma 6. So these are the elements of the relation, given relation, that is R. So from this we have to choose the relation R1. So here R1, the condition is E is equals to. So here the condition or the property is equal to. Then now here the relation R1 will be given by means of the ordered pairs. So from this we have to choose the elements in such a manner that, say here it must satisfy the condition or the property is equals to. Whereas here if I choose the first ordered pair, that is 4 comma 4, so here x coordinate is of 4 and the y coordinate is of 4. So here x and y are equal. So here the condition is of x must be equals to y. So x value is of 4 and y value is of 4. So we can write 4 comma 4 because here x and y coordinates are equal. So here the next ordered pair will be of, so here 5 comma 5, whereas here x coordinate is of 5 and the y coordinate is of also 5, x and y are equal. So here we can write the 5 comma 5 also as the element of this R1. So similarly, so here x coordinate is of 6 and y coordinate is of 6. So here x and y coordinates are equal. So here it satisfies the relation, that is R1. So therefore, so 6 comma 6 also will satisfy this condition. So in this manner we got R1, the relation as 4 comma 4, 5 comma 5, 6 comma 6 as the elements of this relation R1. But we have to write these elements in the roster form. In order to write in the roster form, we have to enclose these elements, that is 4 comma 4, 5 comma 5, 6 comma 6, these 3 elements within the brackets, and we have to separate them by means of the commas. So here 4 comma 4 comma 5 comma 5 comma 6 comma 6 gives us the roster form of the relation, that is R1. Then now let us go for the second case, that is case number 2.